Hi, my name is Adrian Hernandez, and today I will be presenting my AI project named SMART. First, let's start with a rather oversimplified explanation of what a neural network is. We can consider a neural network being a mathematical function that takes an input and produces an output. On AI, we want the output that the function produces to match other outputs that we have for the certain input that it's taking. So, we take an input, we calculate the output, then we calculate a loss from the output that the network actually calculated to what was the true output from the input that was given, and we backpropagate that loss in order to update the function. We repeat this process many times in order to obtain better and better results each time. That is what training a neural network is. For this specific project, what I wanted to do was to generate pictures of paintings. And for this purpose, I elected one specific type of network, a GAN, a Generative Adversarial Network. That's what GAN stands for. G, generative, because, well, it generates something. In this case, it's going to be pictures of paintings. Adversarial, because it's a system of two networks trying to outsmart each other, the generator and the discriminator. For this example, we can consider the discriminator being an art critic, and the generator an artist. And on this network, the art critic is going to tell, or is going to try to tell, if a picture is going to be generated from the artist or generated by an actual artist from the real life, not like the artist network. And then through a training process, they're going to become better and better at this game in order to perform better and to produce best results. Okay, let's explain in more detail how we train GANs, or how I train them for this specific purpose. First, I have two sources for the pictures. I have a dataset that is just a bunch of real pictures, real images, real paintings generated by real people. And then I have my second source of pictures, my generative network, my artist. I'm going to take a picture from the dataset to first train the discriminator, and I'm going to tell him, this is what a real picture of a painting is. Then I'm going to take a picture generated by the generator that at the beginning of the training is going to look like noise pretty much, as you can see in the image. And I'm going to tell the discriminator, the critic, the art critic, this is a picture, a painting generated by the network, so it's fake. Then by this process, the discriminator, the art critic, is going to tell, okay, now I can tell pretty much how it is. And for the next step, we train the artist, because at this point, the critic has become better at doing what it does, but the artist doesn't. To train the artist, we basically make it fit a painting to the discriminator, and we mark that painting as if it was real. Then the loss calculated by the discriminator is going to be the loss of the art critic, no, the loss of the artist to actually match a real painting. Because if it was marked like a real painting and this art critic was already trained for one step, then what it was missing was actually the failure or the loss of the generator, the artist, to actually create a real painting. Okay, so at this point we know that we're marking things like real or fake, but we don't know exactly what is happening on detail. What happens here is that the discriminator, the art critic, it's actually providing more information to the artist from like just if his painting was real or fake. It actually provides information about little details, and it tells him it looked fake because of this, and it looked real because of this. So now when the artist is optimizing itself, there's actually going to be some things on itself that he's going to increase, because that was what the art critic told him that was good about his work for this example, and there are other parameters that he's going to decrease. And this, repeated cyclically, it's going to create the artist to generate better paintings. Okay, so let's talk about the first approach I took about my project, my problem, that was generating art itself. Now, my thinking at this point was, okay, I know what a GAN is, so I'm going to fit it pictures of thousands, and I mean thousands, 10,000 to be more precise, images of art that I got from a dataset of a museum. And I'm going to tell the generator to actually train to replicate this. So that was what I did, and these were the results that I got. Okay, here are my first results. As you can see, they, like, if you look them from pretty far away, you could say that they're real paintings, but they are not figurative paintings, and you cannot spot people on them or special objects. They're just like paintings, abstract paintings. That's what they look like. I mean, they're sharp, and definitely the network got to capture many of the results, many details, but they didn't have like specific objects with them. Like, here are more examples, and as you can see, they still look like abstract paintings, although they look sharp, and like if you look them from very far away, you could say that they're real paintings. But at this point, I realized something when looking at my dataset, because I was like, why wasn't this network generating the results that I wanted? And what I realized is that while I wanted results that looked like this, people pretty much was what I wanted, I had a lot, and I mean a lot of images of this, of images that could be considered art, but weren't exactly what I was looking for on my dataset. And when I mean a lot of images, I'm meaning that like maybe like 20%, 2,000 out of the 10,000 images of my dataset were this. And I wasn't going to delete this all by hand, so I needed to rethink what my goal was and what was my method to get to it. Here's my second approach. Now, I'm taking the first architecture of network that I had before. The same network that I used to generate the images of paintings before, I used it to generate something else. Now, I wasn't able to get a pure dataset of the images that I wanted, portraits, because after revising the results, I realized that that was like a pretty specific thing that I wanted. I wanted my AI to generate portraits, arty portraits. So what I did was, okay, I'm going to generate pictures of faces, and then somehow I'm going to turn them into portraits. I'm going to put an art style on them. At this point I didn't know, and I'm going to get to that later. So I trained my GAN to generate faces of people, and these were the results that I got. As you can see, they look pretty much like faces and people, and compared to the results from before, you can actually tell there's an object here. And at this point, I already had the pictures of people. Now, the only thing that I needed was to actually convert them or to put an art style on them. And for this, I needed to implement something else, something called neural style transfer. Neural style transfer. What I'm going to be using neural style transfer here is to transform the images that I already had of faces into portraits that actually have an art style. Okay, so neural style transfer network, it's different from a network that I already had, the GAN. So for this network, I take a pre-trained BGG19 network, that is a network for object detection, and I just use certain layers of it to extract features of images. For this process, I'm going to need two images: a content image, that is going to be my face image, the face generated by the GAN, and the second image, it's going to be an art style image. This one is going to be from an artist of my preference. In this example, I'll be using Van Gogh. Now, for this process, first I pass the content image through the network, and out of certain layers, there are going to be features of extraction that are going to be the outputs of certain layers. I'm going to actually save and record those features extracted by the network, the features that it extracted from the content image, and then I'm going to do the same for the painting that I want to extract the style from. Now I have my features saved for those two paintings for the layers that I want of the feature extraction of the pre-trained network. And what I'm actually going to be optimizing is a third image that is going to be at the beginning, the same as the content image. Now I'm going to optimize my image of input. In this case, everything on the network is going to be pretty much fixed. What we actually are going to be optimizing is the input image. And we do this by passing the image through the network that I already mentioned, And for each layer, I'm going to compare the features that were extracted from the input image to the features that were extracted from both the content image and the style image. And I'm going to calculate losses for those. And depending on the losses for those features, I'm going to be optimizing the image. And repeating this process over and over is going to eventually make the image to become a balance over the content image and the style image. Here's some examples of this process over the same image and with different styles of artists. Here's a quick demo about the final program. You can see that it generates portraits